Hi, yes. Today our topic is about electronic configuration. First of all, what is electronic configuration? Let us see. Electronic configuration means in an atom there are many shells. According to atomic number, there may be shells. And electrons, for example, sodium is there. It is having 11 electrons. How these electrons are arranged in these shells? In first shell, how many electrons will be? In second shell, how many electrons will be? In third shell, how many electrons will be? Among 11, first shell 2, second shell 8, third shell 1. Like that, the systematic arrangement of electrons in atomic orbitals is called electronic configuration. Systematic arrangement of electrons. Where we will arrange the electrons? In atomic orbitals. Atomic orbitals. So this is electronic configuration. For writing this electronic configuration, there is one method called NLX method. NLX method. N is the shell number, orbit number. This L is the angular momentum quantum number. This is principal quantum number. This is angular momentum quantum number. Means this is shell number, in which shell electron is there, in which orbital electron is there, and this number of electrons. It is the number of electrons. For example, third electron in that orbital, fourth electron in that orbital. So about that we are going to discuss. So next, for writing this electronic configuration, for writing in this NLX form, we need three rules and three principles. Let we discuss the three principles. Aufbau principle. The first principle to write electronic configuration is Aufbau principle. This principle tells that electrons enter into least energy orbital first. Least energy orbital first. So this is the shortest definition you can read in any book. Electrons enter into least energy orbital first. So how energy of the orbital can be known by the electrons? By checking their n plus L value. The energy of energy of the orbital can be found by n plus L value of particular orbital. For example, 3s is there and 2p is there, 4s is there, 3d is there. In these four orbitals, let's find the n plus L value of all these orbitals. N plus L value of 3s, n3, s orbital L value 0, p orbital 1, d orbital 2, f orbital 3. These are well known before only. We have discussed in the previous classes. So 3 plus 0, this is 2 plus 1, 2 p orbital 1, 4 s orbital 0, 3 d orbital 2. So this is 3 and this is 3 and this is 4 and this is 5. In between these two, n plus L value of 4s orbital is less when compared to n plus L value of 3d orbital. So electron enters into 4s but not 3d after 3p. Let we discuss one example also. Electrons enter into 4s after, so 1s, 2s, 2p, 3s, 3p. After 3p, electrons enter into 4s but not 3d. Even though 3d is there, the electrons will not go to 3d because 3d is having more energy when compared to 4s. So first 4s electrons will fill after 3p and then go to 3d. And one more case in this Aufbau principle, 3s and 2p, these two are having same energy. Then electrons enter into which orbital first? When the two orbitals having same n plus L value, electrons enters into the orbital having least n value first. Least n value first when it is having same energy. Least n value first. So electron enters into 2p, then only 3s. Okay, this is Aufbau principle. By using Aufbau principle, Moeller, another scientist, made one chart to fill the electrons, to remember the relative energies of atomic orbitals in which electron has to fill first. Let's discuss that Moeller chart. Yes, this is the Moeller chart to know the relative energies of atomic orbitals. Means every time it is difficult to find n plus L value. That's why it is easy to remember how to how to fill the electrons in the atomic orbitals, in which order electrons have to fill. So first 1s, and then we have to go for 2s, like this 2s, and after 2s we have to go for 2p and then 3s, and then we have to go for 3p and then 4s, and we have to go for 3d and then 4p and then 5s, and next we have to go for 4d and then 5p and then 6s. Then after 6s we have to go for 4f and 5d, 6p and so on. So this is the order. This gives the order of filling electrons in the atomic orbitals. See, like this, in a spiral shape, like this it has to, we have to take the order. This chart representing the relative energies, means which is having more energy and which is having less energy when compared to when you consider n plus value of the atomic orbitals. Okay, this is Aufbau principle. Next, Hund's rule. Hund's rule states that pairing of electrons takes place when all degenerate orbitals are half filled or filled by one electron. So what is this degenerate orbitals? This is only question. Degenerate orbitals means the orbitals having same energy. Example, in a 2p shell, 2px, 2py, 2pz. These three are the degenerate orbitals because their n plus L value of all these three are same, and also n value also same. That's why we can't distinguish them. So all are equally energetic. So these are called degenerate orbitals. Okay, our Hund's rule states that pairing of electron takes place when all degenerate orbitals are half filled. For example, here in 2p, 3 px, py, pz, 3 are there. So first one electron came here. Whenever we get the second electron, means atomic number increases by 1. Next atom, next element. Then what happens? Electron will not pair here. Electron enters into next orbital, next degenerate orbitals, and again next atom for next element, like that. After filling 3 electrons only, pairing starts with the first one, then it will pair with the first electron, and afterwards this one, afterwards this one. So this is the systematic way. According to Hund's rule, the electron has to fill in the degenerate orbitals. So once again, pairing of electrons takes place when all degenerate orbitals, same energetic orbitals, filled by one electron are exactly half filled. So this is the Hund's rule. Let we see how electronic configuration of elements is done by taking a few examples by using Hund's rule. According to Hund's rule, how electrons are filling in the atomic orbitals, let we discuss. First, Z is equal to 1 with hydrogen. hydrogen is having only one electron. The Z means atomic number. It is having only one electron. It is filled in the 1s orbital, 1s1, like this. Diagrammatically you can represent like that. And helium 1s2, like this. Lithium Z equal to 3 means atomic number 3. It has 3 electrons. First 2 electrons enter into 1s, second electron enters into second shell, s orbital 2s. And beryllium, it has 4 electrons, 1s 2 electrons and 2s 2 electrons. 2p will be there but empty, no electrons. Boron, 5 electrons it has, 1s2, 2s2, 2p1. 2 electrons in the 1s and 2 electrons in the 2s and 1 electron, remaining 1 electron in the 2p, 2px. Next, if you go to carbon, it has 6 electrons, first 2 in the 1s, second 2 in the 2s, and next 2 electrons, one in the 2px, other one is in the 2py. It will not pair, it will fill 1 electron in each orbital, because these three are the degenerate orbitals. Same like nitrogen. Nitrogen is having 7 electrons. It will 2 electrons in the 1s, 2 electrons in the 2s, and 3 electrons, one in each of 2p orbitals. And next, oxygen has 8 electrons. First 7 electrons like nitrogen only filling, but 8th electrons pairing with 2px. So this is the way how to electrons fill.